1G. In the 1980s, 1G was the first mobile network. The technology behind 1G used analog signals, meaning phones used radio waves to send voice calls without any digital encoding. This led to poor call quality and limited capacity, as only one call could be made per frequency. 1G allowed for basic voice calls, but there was no text messaging or internet, just voice communication over radio waves. Mobile phones were large, bulky, and mostly used by business professionals. Despite its limitations, 1G paved the way for future advancements in mobile technology. 2G. In the 1990s, 2G introduced digital signals, replacing analog signals with digital encoding. This improvement made calls clearer and more secure. It also allowed for text messaging SMS and picture messaging MMS. The major change in 2G was the switch from analog to digital, which allowed for more efficient use of the available radio spectrum. 2G networks use Global System for Mobile Communications, better known as GSM, and code division multiple access technologies to improve signal quality and capacity. 3G. By the early 2000s, 3G took a huge leap forward with the introduction of wideband digital networks. The key change was higher data transfer speeds, which enabled mobile internet for the first time. With speeds ranging from 384 kilobits to 2 megabits per second, 3G allowed users to browse the web, send and receive emails, and even make video calls. This was achieved by moving from circuit switch networks, which were used exclusively for voice, to packet switch networks, which are more efficient for data transmission. The introduction of Universal Mobile Telecommunications System known as UTS and high-speed packet access known as HSPA helped to increase data speeds and improve coverage. 4G. In the late 2000s, 4G brought even higher data speeds and all-IP Internet Protocol networks. The technological breakthrough with 4G was the shift from traditional circuit switching to full packet switching for all services, including voice calls, which were now carried over the Internet Protocol known as VoIP. This allowed for HD video streaming, real-time gaming, and high-speed internet on mobile devices. 4G networks were based on long-term evolution known as LTE technology, providing speeds up to 1 gigabits per second for downloads. This was possible thanks to the use of higher frequency bands and advanced modulation techniques like orthogonal frequency division multiplexing known as OFDM, which increased data capacity and speed, enabling seamless multimedia experiences on smartphones. 5G. In the late 2010s, with 5G, the biggest technological shift is the use of millimeter wave frequencies and sub-6 GHz spectrum for ultrafast data transfer. 5G also introduces massive MIMO, which stands for multiple input and multiple output technology, which allows for the simultaneous transmission of data to multiple devices over the same frequency. This dramatically increases the capacity and speed of the network. 5G can support speeds up to 10 gigabits per second, which is about 10 times faster than 4G, with ultra-low latency as low as 1 millisecond. The network is designed to handle millions of connected devices through technologies like network slicing and beamforming, making it ideal for applications like Internet of Things, smart cities, and autonomous vehicles. 6G. In the 2030s, 6G is expected to bring even faster data speeds and advanced technologies. The biggest technological shift with 6G will be the use of terahertz frequencies, which will allow for much higher data transfer rates. Artificial intelligence will be integrated into the network to optimize performance and manage resources. Enhanced massive multiple input and multiple output technology will further increase capacity and coverage. 6G is expected to offer speeds up to 100 gigabits per second, enabling instant downloads and seamless streaming of ultra-high-definition content. Latency will be extremely low, potentially down to microseconds, making real-time applications like autonomous driving and remote surgery more effective. With massive connectivity, 6G will support the Internet of Everything, connecting trillions of devices for smart cities, homes, and industries. Advanced applications like real-time holographic communication and immersive extended reality experiences will be possible,